complete all the stations because none of us have been at school. So I'm not sure how y'all are feeling about reading the motions on graphs. So I'm going to make this video. I'm not going to make you, answer this as I go. This is kind of like notes, something you can refer back to. And hopefully it is a little refresher for some of you. And kind of like a review, because at this point you should have done your stations. And hopefully this will kind of clear up any misconceptions we're having. So we have different types of graphs, and this one is a distance versus a time graph. And with distance versus time graphs, we can calculate the average speed. So if we look at our graph before we even read any of that down there, we have three different objects. Object A is blue, object B is red, and object C is green with the different triangles, circles, and squares. And we notice that our time is in hours and our distance is in miles, because the one thing that I know should be a review at this point is that when we are looking at graphs and these word problems, that our units are very important. And again, these are units for time, hours. Units for distance would be miles or kilometers. Seconds could be over here. So we need to get to where we can look at this graph and just know that object B is going faster than object A, or object C is accelerating. All right, so we're going to go through it and kind of figure out how we should be able to look at that and tell it. So it says the shape of the line that represents each object should immediately tell you something about its motion compared to the motion of the other objects. You should be able to make general assumption about which objects were faster, slower, accelerating, resting, or traveling at a constant speed. However, more precise data can also be calculated with this type of graph. The variables needed to calculate average speed of an object are provided by a distance versus time graph. You learned how to calculate the average speed of an object using these variables earlier in this lesson, and we've practiced it a ton. So use the graph above to answer the following questions. All right, so the first question down here, how far did each object travel? Well, I have time on my x-axis over here. Distance is over here, so it asked how far. So I'm going to need to look at distance. Well, if I go and look, all of my objects stopped on this line. That line is 60. And what units is our graph in? Miles. So 60 miles is how far they all went. Number 2, which object traveled at the greatest average speed? Well, if we don't feel like solving for speed right away, we can just look at the lines and we can look at something. So our object A, which is our blue line, they went 60 miles and it took them 60 hours. Object B, which is my red line, they traveled 60 miles and it only took them 30 hours. Object C, my green line, traveled 60 miles in 40 hours. So they all traveled the same distance, which was 60 miles, but it only took object B 30 hours to do it. So he obviously had to be going faster. Oops, and that's why I use this one, because I be making mistakes. God, that's messy. Which object, so B. Was going faster. And whenever you get more used to using these, the steeper the line is, the faster the average speed was on a distance and time graph. That's not the same for other graphs. All right, which object traveled at the slowest average speed? So again, we can look. We all know that they went 60 miles an hour. Well, which one took the longest amount of time? That would have been object A, our blue line. So we know that they were going the slowest. All right, number 4, what is the average speed of object A? Well, we know. How do we solve for speed? S equals D over T, right? So object A is the blue line. So what is the total distance it went? 60 miles over, and how much time did it take? 60 hours. So that would end up equaling 60 divided by 60 would be 1 mile per hour. All right, so we're going to skip down and do number 7. Look at number 7. Because these, we're going to solve those the exact same way. Speed equals distance over time. And you write your units, and you'll leave your units there. Easy peasy, right? So number 7, which object accelerated when it was in motion? So on distance and time graphs, we should know if we see one curve in this way, a curve like that, that means it went faster, right? Because it had this slope that was not very steep, and then all of a sudden right here it started going boop and it got much steeper. So this means the speed increased, right? So a curve like this on a distance and time graph would mean acceleration. So object C. Because it had a curve. Was the average speed of object C between 20 and 30 hours? So now it's given us a time frame in this one, 20 and 30 hours. So if I come up here, it wants its average speed in 20 and 30 hours. So I still have to find the total distance and the total time within this time frame now. Now I'm not worried about what's over here, right? I'm just worried about between that 20 and 30 minutes with my line. So for my distance, first down here I'm going to write S equals D over T because I know that's what I need to do, but I need my distance first, right? So if I look at 20 hours, I was at 10 miles. And then at 30 hours, I was at 20 miles. Okay, so 20 minus 10, altogether, I went 10 miles. Then for the amount of time, I started at 20 hours, and then I went to 30 hours. The time in that is 10 hours altogether. So 1 mile per hour. Sorry, I forgot you couldn't see me down there. All right, so you would do the same exact thing for the next one. It's 30 and 40 hours. So now you would be going from the 40 hours. And again, you would need total distance. So this one's so long, I'm totally going to do that. So I was at 20 to 60. 60 minus 20 would be 40. So 40 miles is the total amount of miles I went within that time. And then the time again was only 10 seconds. Hours. Why do I keep doing that? Sorry. All right, so now we get that it was 4 miles per hour. So we can see by doing that our speed increased, and that's why we saw that acceleration, right? And so the numbers solving it prove to you that, boom, that it did accelerate. So that's pretty cool, right? If you flip it over to the back, on the back you have 4 graphs here, and you have to look at the graph and figure out which one of these scenarios matches. So if we just take a look at our graphs right away, we see that they're all distance and all time graphs. We also see that the blue is going to be Jim and Sally is going to be the red. All right, so we have two of the same people in all of them. And even our units are all the same. We have meters, our distances, and our times are all in seconds. So we all know they're going to be meters over seconds. So let's take a look at this. So graph blank shows that Jim ran a distance of 8 meters and Sally ran a distance of 6 meters. Okay, so the first thing we need to do is look at distance, right? And Jim, he's our blue, and we need him to go 8 meters. So if we look at this one, he started at 0 and went all the way to 10. So he went 10 meters. That's not our graph. Here, Jim again is blue, 0 to 10. He went 10 meters. We need him to go to 8, right? So here, Jim started at 2, and then he went to 10. So 10 minus 2 would leave us 8, right? So he went 8 meters right there. And let's look how many he went here. He was in 2. He started at 2, went to 10. 10 minus 2. Jim is 8 meters again. But what did we need Sally? We needed her at 6 meters. So Sally on this one started at 0, went to 10. She went 10 meters. That's not going to work. Sally here started at 4 and then went to 10. So 10 minus 4 would equal 6 meters, and that's what we needed. So this one is graph D. All right, the next one. Graph blank shows that Jim and Sally started from the same place, so they need to start from the same place, and Sally ran at a greater average speed than Jim. Okay, so if it's a greater average speed, when we look at this one over here, this one had a greater speed and its slope was steeper, right? It was a steeper line than the blue one over here. So we need Sally to have a steeper line than Jim, and we need them to start out at the same point, right? So we can see they started at the same point there. That could be our graph. They did not start out at the same time there, but they did at the same point. That could be our graph. We already picked that one. So this one, they started out at different points. She started at 0 meters. He started at 2. So it's between these two up here, right? So if we look at this one, they both started at the same distance, 0 meters, and Sally had a steeper line. It only took her 8 seconds to go 10 meters, while it took Jim 10 seconds to go 10 meters. So that one is graph A. The next one, graph blank, shows that Jim and Sally did not start at the same time, but they both ran the same distance. Okay, so they didn't start at the same time. We have graph B and graph C. Well, Jim started at 0 seconds. Sally started at 2, right? And over here, they both started at 0 seconds. So we know that's graph B. So then for the last one, we think it should be C, but let's check it out. Graph blank shows that Jim and Sally started from different places. And I guess I should underline that at the same time, but they both traveled the same average speed. So we need to compare that too. So different places, the graph we need it to be graph C, that marks out, right? And they had the same average speed, meaning our slopes would be the same. And here they are, parallel, exactly the same. We just started from different meters. Okay, so that is C. So hopefully this kind of goes over with you guys enough to where you are understanding it. You will have some practice questions over this, so it's very important that you watch this and refer back to it when you need to. All right, hopefully y'all are starting to figure it out and it's making sense.